my viewpoints to all this work. I hope that it was helpful for everyone. The key idea is that I think that it has been nice to see all the points that were considered when thinking about how to handle this problem. To be honest, I have found one point that maybe is not of interest for you, but in many regions in Spain, we have pressurized networks to deliver water to crops, and we are facing the problem of wanted to match power consumption with irrigation. So I think that maybe you could think about considering energy as a point to.
So what water energy nexus or something like that.
Yeah, something like that.
Okay.
And and I will tell you something additional that maybe is just far away from here, as we are. As the fields are located far from the cities, we are also we are finding that many irrigation networks works as standalone systems. I mean, there's not electricity there. So they are off grid. They have solar installations for supplying power to pressurized irrigation network. Finally, with all these ideas that come to my mind, I would like to tell you. Moreover, you can have some limitations, and this also applies to other works, because you can have limitations. Imagine that you are taking water from the aquifer. Maybe you have a limitation for this aquifer, and so you cannot irrigate as much water as you want. And finally, you have also a limitation of your infrastructure, because if you want to irrigate very quickly, taking advantage of these hours in which energy is cheap, or when you have irradiance, if you're thinking about photovoltaic solar panels, you can have, it's very unusual, but maybe you can have a limitation with sizing of this infrastructure. And so these are the ideas that come to my mind. And finally, the point that can be of interest for you is, what do we want to optimize? When we are thinking about irrigation scheduling, we want to minimize water consumption. We want to minimize energy consumption. We want to increase yields, the crops. We want to earn more money. I think that scheduling, the views that you show are very interesting, but maybe you can take this one.
Okay, thank you.
And sorry for the long talk. Sorry, my friend.
No, it's good. I think me and my colleagues will be, and all participants in the review. It's good that we have this talk. That's good to get ideas. Thank you.
Thank you, Miguel.
Oh, any other questions or suggestions? If not, we can continue with another presentation from Alba.
Yes. Good morning to everyone. Can you hear me?
Yes.
Okay, perfect. So I'm going to present the advance of Kiwifruit Group. As already told by Professor Di Chio, this is just a preliminary analysis because of it should be, we should go deeper with the all groups, and we would like to invite all of you that could enjoy and join our group. So from this preliminary analysis, using the keywords that was decided by internal the work group 3, this is the first analysis, and also we would like to pay attention to the period in which we find different papers in the literature. It was started approximately 90 and till, of course, these years, with an increase in the last 10 years, probably due to the spreading of this cultivation, this crop cultivation in a different area that was areas that were more, in which were more needed the irrigation, and probably also due to climate change. After this first analysis, we didn't find a specific review on kiwi fruit and irrigation. And so this is a very first important point. But from this analysis, we also found this review of the last month that is interesting, in which the climate change impacts were reported, in particular for the kiwi fruit production. And the authors analyzed several papers, focusing first of all on the main effects of climate change that could affect, of course, kiwi fruit mainly, and also focusing on the possible strategies or approaches that could be improve the adaptation of the crops cultivation, kiwi fruit cultivation in the different areas. And among these strategies, a very important part is water management, according to the points that you can see in this table. And could be, we think that these first points could be also useful for our review. After this first analysis, we, of course, this is we create this first draft that we would like to discuss with all of you, and then in particular with the members of the group of the Kiwi Fruit Review. This is the results, of course, of the first backbone proposed by Martin and discussed with all the group, but also in taking some consideration from the working group 1, that I'm leading the Kiwi Fruit Review in working group 1. So because we think that there are some aspects that maybe could be overlapping, so we need to pay attention to this aspect. So after the general introduction, we would like to we think that it could be useful have a paragraph on climate change impact, also according to the previous review that I showed you before. Then we have a chapter on water requirements, even if this is in particular, we should need attention to avoid overlapping with the Kiwi Fruit Review of Working Group 1. And on the following chapters will be on soil volume explored by roots. Also, according to what Miguel Costa was saying, we think that this is very important aspect because of it is important to calculate the soil volume wetted by irrigation, explored by roots, and also how the root growing change according to the different irrigation systems. For the following chapter, the irrigation methods, of course, this will not only a description of the methods, but also we would like to see the experience on how the main constraints and the advantages of each methods. And we think that it's very important to focus on the design of irrigation systems, because it's important to consider the different age of planting of the orchards, and also the different soil conditions, and in the areas that with the high water demand and environmental water demand, is very important to have an automated systems. In our experience, during summer we irrigate kiwi fruit also 4 or 5 times per day. So it's, these systems are very, very important. The following chapter is related to the irrigation management with, of course, strategies and scheduling, with the main focus on optimal irrigation. So all the strategy, all the strategies and tools needed to respond to plant water requirements to give an optimal irrigation without water losses. For kiwi fruit, the regulated deficit irrigation could be done only in particular areas. It is not so spread like other crops. And of course, we would like to put a paragraph on the zoning management because of it's important also consider the soil orchard variabilities. The other chapter is related to the indicators and tools to guide precision irrigation. So all the aspects related to the monitoring of environment, soil, plant sensors that could which results could be integrated and give some information to guide more precision irrigation. We also agree with the idea to prepare a chapter on all the other agronomic practices that could increase the water use efficiency, canopy first and then soil. So different moments of prunings, netting, mist irrigation in some cases. And from the point of view of the soil, of course, cover crops and mulching to increase the humidity, soil humidity. And as was already discussed before by Miguel Costa and by Professor De Chio, we think, but we of course would like to discuss with all of you, that a chapter on water productivity and the water governance could be very important in this part because of about the importance of the crop in particular areas. It is important also to pay attention to, for example, economic water productivity of that crop and on the impacts, not only environmental but also social and economic impacts that this crop cultivation could be in a particular areas. So, and of course, at the end, the conclusions with the further perspectives and all information related to irrigation, precise irrigation, and so on. Thank you.
Thank you. Alba, there are any questions or suggestions from the audience or online? Very nice to hear that most of the groups have really comprehensive idea how to approach the reviews. So I'm very happy to hear that even the groups which just started to do their work are even quite straightforwarding in their ideas how to approach the reviews. Thank you very much for the presentation, and if no other questions or suggestions are present, we can maybe continue with Annabella, her presentation about olives.
Hello, everybody, again. Can you see my screen, the
Yes.
presentation?
Yes.
Okay, you are talking about literature review state of the art in olive irrigation. Our analysis is quite is a little different. You summarize here the many conclusions that the review papers published focus. So among about the 20 review papers, you can summarize the different aspects that they have focused the review. For example, a better understanding of the effect of different drip irrigation designs and treatments. Another focus on the review on water relations and irrigation needs of olives are collected and summarized in attempt to link fundamental studies on crop physiology to irrigation practice. Another one revised and provided advice on methods for estimating and applying crop coefficients for an observation of ground cover and vegetation height. Another review focused on deficit irrigation strategies like regulated deficit irrigation or partial root drying can be effective options for high density olive orchards. With this kind of irrigation, it is possible to implement agrosystems with cover crops, no tillage, and recycling of prunings residues. Another one focused on recently gained insights into drought stress in olive trees, drought omics and phenomics approach to unraveling mechanisms that may lead to developing new varieties that are tolerant against drought elicited by chance in growing systems. Another review focused on potential, opportunity, and the limitation of sustaining olive oil production in the Mediterranean region using wastewater of various sources. Many studies have shown that saline wastewater have been successful used to irrigate olives, like in Greece, Israel, Italy, Jordan, and Tunisia. And olive trees are appropriate candidates for the use of recycled water as irrigation source. Another one focuses on overview of the state of the art of technologies that can be employed and current application and their potential for precision oliviculture and precision irrigation, and discuss the challenge and possible solutions and implementation of future technologies, check Internet of Things, and named ground vehicles and machine learning. Another review paper focused on great potential of deficit irrigation to improve the water productivity and the control of soil sanalizations by combining the use of deep irrigation technology with deficit irrigation strategies and by employing the natural leaching of salts by the rain. Another review paper focused on irrigations with saline water, maintaining the soil permeability and induce the distribution of salts outside the root zone. Drought and salt stress alter the olive tree capacity and potential yield in an irreversible way if their severity is very intense. Another review focused on evidence showed that the great potential of plant-based methods as compared to those using measurements of soil water status or atmospheric demand. Combining plant-based measurement with remote measure and user-friendly application for smartphones, tablets, or computers, effects of irrigation on the production of both fruit and oil. There is another recent chapter that I can't access, but another review of water used by olive tree, plant characteristics and mechanisms of drought tolerance, crop response to deficit irrigation, strategies, and to the use of wastewater for irrigation tolerance. Another review paper that focuses on plant response to nutritional aspects, environmental considerations, the effect of irrigation on nutrient availability and the uptake is very significant. Application of organic matter, for example, manure compost and cover crops can serve as substitute for mineral fertilizations with additional benefits of soil properties. Another paper focuses the research on the FAO 56 single and basal crop coefficients of fruit tree and vines performed over the past 25 years. Another review paper focuses on the use of stem diameter variations records for irrigation scheduling when combined with their aerial or satellite imaging. Stem diameter variation measurement are useful for scheduling irrigation in large orchards with high crop water stress variability. And another research review focuses on two approaches to estimate olive evapotranspiration. One approach followed the traditional crop coefficient approach, while the other used a model to partition the evapotranspiration into its two components, evaporation and transpiration. Another paper focused on several field studies report that exposure to moderate levels of salinity did not negatively affect yields. Additional salinity appears to contribute to positive attributes of olive oil. And I think is the last review paper focuses this review on research on the FAO 56 crop coefficients of fruit trees and vines performed over the past 20 years. And the aim of this paper was to update information and extend tabulated single and basal standard crop coefficients. After this exercise, you have slight ideas about the published review, and you ask what direction should we take in our review on olive irrigation. For example, Alain Bengal suggests that tools and strategies for regulated deficit irrigation of olives for olive oil maybe is an interesting approach. You can focus different cultivars and environmental conditions, response to different deficit irrigation strategies, yield and olive oil quality, economic water productivity, irrigation scheduling, sensor and sensings. So you need to make progress in collect literature and discuss the backbone to have an idea, the direction to follow on your review paper. And it's all for my part. Thank you for your attention.
Thank you, Annabella, for your presentation. Any questions or suggestions from the audience? Or from online? Would it be interesting to compare among or between the cultures which are focused to, let's say, bring up to grow the olives for oil with those which are grown for the fruits, for selling fruits, in order of the irrigation requirements?
Maybe is an option. The production for table olives are important in some countries like Turkey, Tunisia. Maybe you can add different kind of production for oil and table olives. Yeah. I take note your suggestion.
But on that note, the irrigation and the whole world of irrigation around oil is much more interesting than irrigation of table olives.
Do you expect that there are many differences in this?
Huge differences, yeah, and it's different crops, especially as irrigation goes.
Yeah. Is there any literature which explain this?
I think it's trivial. I think anyone who's interested in olives understands the difference, and it's not that interesting. But it certainly can be mentioned, but it won't be a big part of it.
That's why I asked it. It was rather a question than a suggestion.
Yeah.
Because I don't work with olives. Well, Olfa, please.
Yeah, just a question. Are you planning to separate topics, very high densities and olive and old olive fields, and installation of higher density, ultra density? So this is very important, I think, for the future.
Mm-hmm.
And then about the salinity, the use of saline water, you present several works done in Tunisia. I think that is like in grapevine, you have to focus also in the soil, because it depends. All these works are done in the southeast, in which we are mostly at 90% of sand soil. If you go to the southwest of Tunisia, it's a clay, and we have a big destruction of the soil architecture. And so the saline water, I think, should be stayed in the review with caution and taken in consideration the soil type.
Okay. Yeah, it is. You indeed did our approach with different system of production. Yeah, the response are different. Traditional olive orchards or high density olive orchards, the response of regulated and deficit irrigation are quite different. It makes sense to separate and do the approach with different production systems. Alpha, I present a review papers of saline water we don't know if you maybe you did this approach in our review.
I didn't get your question.
No, it's not a question.
No.
I have presented review papers that are published.
Okay.
To do a synopsis.
You are not considering to put it in your review, this part of...
You have to discuss. You have to discuss.
Okay.
Another alternative source of water to irrigation, for example.
Okay.
Wastewater, okay? You need to discuss in our group.
Okay. Great.
Okay, thank you.
Thank you.
Teresa?
Yeah, thank you, everybody. Just to add a small comment on this, the papers, the more or less 20 papers, review papers about olive that we found, well, it came out that one of the most representative subjects was salinity, but I am totally in agree with Alpha that we have to look for the regions where the papers, the data for the papers are coming from, because it's one thing if, I don't know, we have 5 papers from completely different situations about the same subject, or if we have 5 papers from the sandy soils of Tunisia. So I think it's, of course, something we have to discuss within the group. But yeah, I think, of course, we must look at those aspects. But it's what happens, what came around in the literature search anyway. It's remarkable that it is so significant, the subject. I noticed, and I don't work with salinity, but so it was a surprise for me. Thank you.
Okay, I have another additional question. The subject for more the Mediterranean crops. Would it be interesting to include maybe not only deficit strategies, but on the annual meeting, I was a part of a discussion about, let's say, identifying the limits for growing the crops themselves, the trees, to sustain when the water is really, really reduced and you cannot irrigate. If we know the limits for examples for olives, what is the minimum of the water to save the tree?
In olives, it's not a big deal. Olive has been rain-fed since 2,000 years.
Yeah, but
probably is the best adapted crop to rain-fed conditions, and it can be extended to most of the Mediterranean crop. I mean, survival won't be a big issue.
Olives survive. They don't produce so well, but they survive any drought you give them.
Okay,
Yeah,
olives
like
maybe not the best example for the crop, but anyway, there are a lot of other cultures.
Like, for example, in olives, the classical rain-fed production is the very extensive, very wide production system, like far away trees. In the most high density or super high density orchards, we don't know actually what if they will survive or not.
I think the question is more,
and not only the survival, but like the maintenance of a minimal production.
I think one of the key questions, and there is some research in this line in almonds, it's if you have, and this has to deal with political issues. So if you have a plantation high density, super high density, that has been irrigated with a certain amount of water, what happens if then the government decide to cut off the water because there is no more water?
From well irrigated to...
And then which strategies you should follow? That should be an interesting question, because my belief is that if you start an orchard already under rain-fed condition. There are the trees, especially Mediterranean species, are plastic enough to adapt to that condition. The problem is that if you have these sharp changes in the water allocation, I don't know if this makes sense.
Omar, I can add something for you. In Tunisia, it happens. They stop irrigation, and basically the plants died.
Yeah,
So,
it happened also in Cordoba.
So it happens because we have a big problem of water, and they decide several regions they don't have irrigations. So basically they lose everything. So for now in Tunisia, the area for super intensive, the olive tree doesn't exist. For the future, they are not planning to do it.
It depends of the type of soil.
No, they stopped. It was like this year you were not irrigating. So it was like, no.
But I read in the literature there are a tentative to convert super intensive to rain-fed conditions. I think it depends on kind of soil. Yeah.
So if we do it step by step, maybe. So we try to put the roots and we reduce it. So maybe to reduce one tree and letting the other one, maybe like that, it works. But step by step. But if the government decide that this year in one region they were not irrigating because we don't have enough water, what happened in Tunisia? The trees died completely.
But this it's not a species dependent thing. My point is that if you think the tree as it is, the tree is able to sustain rain-fed conditions to live under rain-fed conditions. It's a orchard configuration issue. So you are just putting the trees with not enough soil to explore, and this can just. So these are two different things. One, if the species will survive, that I think is Martin kind of question, and the other one is which type of orchard configuration will be suitable in different regions now and in the future. And those are two different questions.
And also the root zone, what you said, the volume of roots. If the plants are used to receive the water just very close to the trunk, they will limit the root growth, and they will not explore a greater areas. So, and then if you from one year to the other you cut like 80% irrigation, you will kill the plants because they are used to take all the water close to the trunk. So yeah, we need to consider all these aspects.
Yes, I think Alan knows very well in Turkey for olives. There is most olive trees on mountain, and knows never irrigated and rain-fed conditions and never die. But yield not very high, but olive oil high quality, and but most of olive trees is a different climates, different soil types.
Yes. Not dedicated just for olives. So certainly there are more susceptible crops for such thing. But I mentioned such discussion on the annual meeting, and it was interesting to think about whether there are some presented already described limits on some crops. Okay, that's all. So any other ideas? If not, we can continue with the last presentation from the chain. Yeah, okay, you could.
Hi everyone, again, a short presentation because I have to say sorry. We have not done. We have done a few things.
How people try to explain this? Didn't work on it.
Up to now, we reviewed the paper. We have the covering this those issues: irrigation scheduling, soil content, deficit irrigation, stress, water deficit or salinity, soil and water, physiological response, and orchard management practice, mulching or core crops, and gaps in review papers we reviewed up to now. Plant response, photosynthesis rate, saplo, for example, and remote sensing. And numbers of literature classifying. I'll show for presentation, FruitCREWS presentation, irrigation, anatomy, canopy, fruit and root stocks. What will we do during process, especially after this meeting? Reviewing all literature, VG1 or PEACH, and different literature according to subject, deficit irrigation, evapotranspiration, growth stress, and etc. And sharing literature to participants, and we will do the other issues related to each. Okay, thanks for your attention. It's a short presentation. Any question, any comment, or any suggestion for processing? And I would like to thank again Martin, because he supports every time my email or my phone. For I'm sure that he will do again after this meeting and process the review the letters and all the another issues.
Okay. Well, thank you. So, any suggestions or comments? This was really a quick overview.
Yeah.
So you will have to maybe do more elaboration and to or discuss with your colleagues the main ideas on what you want to focus on.
We have a lot of work to be done. Yeah.
Any ideas or experience from fruits and their growing and irrigating requirements, or ideas from the literature? If not, I think we can close section.
Before closing, maybe just some brainstorm that it might be applied to all the group, and it's related to the interaction between the rootstock, which is commented with Victor. The relation between the rootstock, the scion, and the water requirements. I'm not an expert on apple, but my feeling is that most of the rootstock have been developed for things that have nothing to do with water requirements, water demands, and maybe just proposing or searching for works that link this rootstock scion interaction with irrigation scheduling programs, water demands, and everything might be interesting for the goods, the crops that use rootstocks. Because there's
is the main thing, because different rootstocks have different water availability on different cultivars.
And they include, in general, also the total growth of the scion. So, in fact, we will get another size of the trees.
One of the key questions is the link between the irrigation programs that might be general for apple, and which one can be applied to certain rootstocks, and which one can work.
The question,
I don't know, something like that.
Also, yeah, it's a good suggestion. The question is also the ability of that cultivars or crop combinations to take the crop load, because The thing is that, for example, we have compared some deployed cultivars of apples. We worked with Gala and with red Fiona Prince, which is a Fiona dot. So it's small, vigorous cultivar. I will present it later. And we got different results in the natural D-ring and also in the reactions of the trees for water given by radiation. So yeah,
maybe it would be useful for the apple years because the very wide range of the rootstock compositions, also peach and nectarines, GF rootstocks and other rootstocks used. But the other fruit crops, maybe it couldn't be as well.
Yeah,
if it has a many wide range of the rootstock composition, yes, we can select. But the another important factors, as you say, the cultivars and the rootstocks combination, because it's very difficult, I think. Many factors affected by these positions, the soil environment, and we select. We have already selected the soil and the water content, water potential. We select the rootstocks and the cultivar. We grafted on the cultivar, and then we can decide how much water we need. And also the air temperature, especially in Mediterranean region, suffer from low water potential. Many growers gave up the dwarf rootstocks because we don't have enough water. They gave up. They preferred wild or semi-dwarf rootstocks, and the government supported this position. So it's a good idea, but it's a little bit, I think, difficult.
Yeah.
Many factors.
We will need to process many articles for us. But yes, it's a good suggestion. Thank you. Well, I guess there are many aspects we can discuss continuously, and if you have any ideas or suggestions of what could be done in particular crop, and then globally for the crops, for the reviews or for the knowledge not so often presented, please feel free also to discuss during the other sections or later. We will in the afternoon we will present some experience or some examples of processing of the literature, and also in this way. So we have had a look on rootstock effect and also on cultivar effect. So we will try to synthesize a bit about the crop growth and production and about the water requirements and their connections. So feel free to make anytime suggestions or discuss during round or so on. Good. Well, if nothing else, we can try to take our lunch.
Yeah. So the cafeteria is close to the rectorate. If you are lost, then go to the highest building.
We will go all together. Thank you for till now. Thank you for all the online presenters, and we will continue.
Martin, we can leave the stuff here.
Thank you. Bye bye.
Bye bye.